0.3 and yesterday we finished with cross product. So today what I want to remember, which we also talked about this yesterday, but this is going to be really important for today. Recall that orthogonal vectors, okay, their dot product is equal to 0. Okay, so here's our first example. Example 1, we're going to do u is equal to -10, 0, 6, and v is going to be equal to 7, 0, 0. Okay, and what we want to do is we want to find u, the cross product of u and v, and show that they are orthogonal to u and v. Okay, so what exactly does that mean? Well, we need to do u times v, which remember, I have I, j, and k on the top. And I'm going to use u as a -10, 0, 6, and then 7, 0, 0. Okay, so what I have here is I'm going to have I times 0, 6, 0, 0 minus j. Cross out that middle section, so now I have -10, 6, 7, 0, and then I'm going to have k, and k is going to be -10, 0, 7, 0. Okay, so I have I times 0 minus 0 minus j times 0 minus 42. And then I have plus k times 0 minus 0. Okay, so what I actually get is I get, this ends up canceling. This cancels. And so I have a positive 42j, which means I have 0, 42, 0. And what I'm trying to find is that u times v with the dot product of this with u, well, let's figure that out. So I have 0 plus 0 plus 0 gives me that 0 I was looking for. And then this cross product of u and v, dot product with v, is going to be 0 plus 0 plus 0, so I get 0. Okay, so I have, number 1, found the cross product of u and v, and secondly, I have shown that it is going to be orthogonal to u and v. Okay, now we're going to talk through a few properties. So if I have some algebra properties here, oh my god, I can't spell properties. Okay, so I'm going to say that the cross product of u and v is equal to a negative v cross product of u. Okay? And then what I can also say here is, let's say I go u with cross product of a v plus w. It's going to be the same as if I did the cross product of both u and v, and then I added the cross product of u with w. Okay? So those are some algebra properties. We're going to talk through geo properties, geometry. Okay? So we have geo properties. All right, I have number 1, u cross product of V is orthogonal to both U and V, which we just found, right? We were just able to prove with one example. Okay, we're going to do number 2. This one's going to come up later as well. The magnitude of that cross product of U and V is going to be equal to the magnitude of U times the magnitude of V sine theta. Okay. Then if for some reason you pull out, you go, oh, well, let me do the cross product of U and V and I get a 0. That will occur if and only if, remember, this is the way we write if and only if, U and V are scalar multiples of each other. Whoa, hello? Are scalar multiples of each other. Okay, and then the last thing, so I'm not gonna give you an example of this, but you're gonna have this question on your homework, is going to be the magnitude of U cross product with V is going to equal to the area of a parallelogram having U and V as adjacent sides. Well, okay, so it's literally going to ask you to find this. You need to know that this is the equation you're going to use. Okay, now we're going to do some other examples that you're going to see on homework. Okay, example 2. We are going to find the unit vector orthogonal. Hello? Orthogonal to both U and V. Okay, so U is equal to, I'm going to go to -3, 4. Oh my goodness, what is happening? This pen better not give out on me. Okay, and then V is equal to 0, -1, 1. Okay, what is our goal here? What we're trying to do is we're trying to find the cross product of U and V over the magnitude of the cross product of U and V, right? Which makes sense. The unit vector is normally V over the magnitude of V. Well, this time we're trying to do a lot of cross product things. So I need to find the cross product over the magnitude of the cross product. Okay, now we should be able to do this. So I'm going to go U cross product of V and I'm going to give you the answer. Is a -6i minus 3j plus 6k. Right? And I need to find the magnitude of this. So I have the square root of -6 squared plus -3 squared plus 6 squared. Come on, pen. Do not give out on me. Okay, which is the square root of 81, which is 9. So what I have here is when I go the cross product of U and V over that magnitude, I have -6i minus 3j plus 6k all over 9. So my final answer is a -2/3i minus 1/3j plus 2/3k. All right. Sorry, I'm flipping my page over here. Okay, now we are going to find the area of given vertices. Okay, so a triangle is what we're going to talk about now. Okay, so we have the area of triangle given vertices. And our equation we're going to use is the area is equal to 1/2. And we're going to use the magnitude of AB and the cross product of AC. Okay, so what we have here is we have A is 2, 3, -5. B is -2, -2, 0. And C is a 3, 0, 6. Okay, so what I have to do is I have to go from A to B and then C to A. But remember, I always have to go terminal minus my initial. So in order to find that, I'm going to say AB is -2 minus 2, -2 minus 3, and 0 minus a -5. Oh, okay, so what I end up getting is -4, -5, and 5. All right, then I have to still find AC. So AC is going to be 3 minus 2, 0 minus 3, and then 6 minus a -5. So my final answer there is going to be 1, -3, and 11. Right? And now I have to find the cross product of these two. So let's just, for the sake of things, call this U and call this V. Okay? So what I'm going to find now is I'm going to find U cross product V. Well, I have I, J, K. I have -4, -5, 5, 1, -3, 11. And so when I go through the setup of all of this, I'm going to have I times -5, 5, -3, 11, minus J. J is going to be with -4, 5, 1, 11, and then plus K, and K is -4, -5, 1, -3. Okay, right? And so after all of that, you get -40. What is this? 49 and 17. Okay, but that's just the cross product. Remember, what I still have to do is I have to go 1/2 times the magnitude, of the cross product here. Okay, so let's find that magnitude. I have -40 squared plus 49 squared plus 17 squared. Okay, and when I do that, I get 1/2 the square root of 4,290. Okay, and we can leave it like that. Okay, unless it tells you to round to a specific decimal, you can leave it there. All right, now we are going to talk about the triple scalar product, and then we will essentially be done. Okay, you have the triple scalar product given U is equal to U1I plus U2J plus U3K. You're going to have a V, which is equal to V1I plus V2J plus V3K. And then you're going to have W, which is equal to W1I plus W2J plus W3, oh my goodness, W3K. All right, now, here's what we're going to do. We have U times the cross product of W. Okay, what that does is we're just finding U1, U2, U3. I have V1, V2, V3, and then W1, W2, W3. And remember, these straight lines should tell you automatically that we're trying to find the determinant. We struggled a little bit on the last time we were doing matrices. We couldn't understand that this right here is a matrix when we have bracket looking things, and straight lines are determinants. Okay, so we need to know that when we set this up, we are trying to find the determinant. Okay, there's going to be a question that's going to ask you to find the volume of a parallelepiped. What in the heck is that? Okay, this right here is a polyhedron where all faces are parallelograms. Not necessarily something we go over in geometry. Okay, but how exactly do I find this? Well, I need to find the absolute value of U V times W. Okay, I believe you only have 2 problems like that. But that is it. Please make sure that you upload pictures of your notes and then get going on some homework. If you have questions, please feel free to message me on chat, although I won't be very responsive today, to be honest. So I can help you on Friday when I see you guys. Alrighty, have a great rest of your day. Bye-bye.